All right, ladies and gentlemen, you should have your projectiles number 1 worksheet, and we're going to talk a little bit about problem number 1. And after, what I want you to do is you're going to kind of go through this with me, and then after we do problem 1, I'm going to kind of let you go on your own. You should complete as much of the T-charts as you can by identifying information in the questions, and then you should go back to look at which formulas you should be using to solve for what. Okay? So I have my T-chart here already created for me, horizontal and vertical. So really this is just my X and this is my Y. All right. I have a softball that's going to roll off of a 95 centimeter table. That is talking about the height. So this is 95 centimeters. Well, we don't want anything in centimeters because our acceleration is in meters per second squared. So we always want to convert everything from centimeters to meters. So if we're going to do that, we're going to have 95 centimeters, and for every 100 centimeters, there's 1 meter. So we're going to divide by 100. So this is actually going to be a y value, and it's going to be my dy. So I'm going to put 0.95 meters right here. It's going to strike the floor 80 centimeters from the base. So that's actually my range, 80 centimeters right here. Again, I'm going to have to convert. So I'm going to have to say that 100 centimeters is 1 meter. And that will make this dx value a 0.8 meters. Now, I want to find out how much time it takes. That's all I can get from my question. So I've filled out my T-chart, except I also know as this falls off the table right here, what is its original velocity? Hopefully somebody said 0. Again, you can talk to me even though I really can't hear you, all right? So this also will go in my T-chart here as 0 meters per second. So then I want to know how much time does the ball spin in the air. So I told you, I gave you the hint of find the t in the vertical. Well, if you remember, when we find the t in the vertical, we can use t equals the square root of 2 dy over a. Okay, so I'm going to take t equals the square root of 2 times my 0.95 meters divided by 10 meters per second squared. Fill this out exactly as you see it on my screen because, guys, you have the time to. And this is an important worksheet that kind of gives you all the different types of problems we will be able to do. So what we'll do now, plug it into your calculator. And everybody should come up with a value. Use those calculators. You should get 0.43589 in your calculator. Don't forget to square root it. And so that would be our answer for B. We want to find the time in the vertical. So I'm going to actually go ahead and put that up in my T-chart too. 0.44 seconds. And if I know that's the time, then I know that it also goes over here too. So this is 0.44 seconds. Now, how fast did the ball roll off the table? So I'm trying to find the Vx. Well, if you remember, I told you Vx, the only formula I can use in the x-plane, is my dx divided by my t. So I have my dx, it was given to me as 0.8 meters. I have my t value as 0.44 seconds. Again, use that full value that's in your calculator. And now type that in. 0.8 divided by, go up and highlight your previous answer and bring it down. And you should end up with 1.84. And that is going to be meters per second. Now I also want to know how fast it's traveling vertically when it hits the floor. Remember, if accelerating, it's going to change velocities. So it originally started at 0, and it's going to accelerate 10 meters per second every second. So I have to figure out what it's going to be right before it hits the floor. So I'm going to use my A equals VF minus VO over T. I could use that one. I could also use my A equals VF squared minus VO squared over 2D. Either one of those would work. I was actually given the D value, so this one, in my opinion, is a cleaner formula to use, but either one will work. So I'm going to manipulate this one, though, because this is the one I figure most of y'all are going to pick. So I would say that this is VF equals V naught plus AT. So that would be it manipulated. So VF equals 0 meters per second plus 10 meters per second squared times my let me move this around for a minute. Go up there. Okay, back here. 0.44 seconds. And so I'm going to go back up in my calculator, and that's why we keep all this information. And I'm going to highlight my 0.04359 value that I had previously. Then I'm going to multiply it by 10. And then I'm going to get that my final VF velocity is going to be 4.35. Actually, that's 3 point, or 4 point, erase. VFY. It's going to equal 4 point, and it's 4.3589, so it'll round up to 36, and that's meters per second. All right. So that's to get you started with this one. Again, if I went too fast, have them just pause this and leave the screen up for a while. But you guys should be working on the rest of it. It's a pretty good sized packet. And primarily, always start with just filling out the T-chart. Then go from there. All right. On this first one, you're asked, or on the second one that you're going to do by yourself, you're asked to solve for the dy. You have a formula for that. And then you're going to be asked to solve for the dx. Then you're going to be asking for how fast was the penny traveling. You need to think about your facts because this is talking about horizontally on this question. Okay? Then on number 3, fill out your T-chart. How long does the bait take to hit the water? So this is your T value that you're looking for. Again, find it in the vertical. It's always easier to find it there first. Okay. Then you're going to find your V, Fy, and then you're going to find your Vx, and then your range, remember, is your Dx. And then resultant, remember resultant is that you're going to use an x value and a y value, and you're going to find your VR, so you really are finding the hypotenuse, and you're needing to find the theta as well. Okay, so you're finding VR and theta. And then on number 4, you have a T-chart again. How high is it flying? So this is a dy value. How fast was it flying? This is a Vx value. How fast was the package falling vertically just before it hit? So that's a Vfy value. And what is the resultant? So again, you're looking for your VR and your theta. All right. On that one's just asking for the VR because the next question asks you for the theta. So this asks you for the theta. And then, again, you need to think about your rules when you think about F. All right. On number 5, again, it's a springboard. And so fill out your T-chart. How much time? So T, again, find it vertically. How fast? Vx. How fast does he hit vertically? So then that's going to be my Vfy. What's the resultant? Vr. And what's your theta? Okay, so all of this is the same type of problem each time. You just got to work your way through. Again, any of this needs to be paused so you can get this down. Just have the sub pause it, and you guys can work through it. Have fun.